All right, mic check. Audio good? Good. All right, awesome. All right, good afternoon. Welcome to B-Sides. I know this is like the end of day talk, so hopefully I keep you entertained and don't bore you too much. So I'm a senior security engineer working in the DoD. This talk, like was introduced, is collecting threat data using distributed deception. So who am I? I've got a background in computer science, spent some time in the military doing maintenance, specifically on tank vehicles. So then I transitioned to cyber once the Army said, hey, we have this thing called cyber, and we're looking for people that are interested in that. So because I have a non-traditional path, my nickname became the mechanic. So you'll hear some people refer to me as the mechanic, and that's the reason why. A few years ago, I started this thing called Smash the Stack with a couple other people, and I still run that to this day. If you're familiar with Over the Wire, it's kind of like that, but it's a little more advanced. So you can Google that and look that up. And then I dabble in a little bit of cryptocurrency. Now, when I'm not messing with anything technical and I want to take a break from everything cyber, I spend time with my family, I'm riding my motorcycle, or I am watching some kind of movie or fiction, right? Specifically anime. If you recognize any of those up there, then kudos to you. All right, so we're collecting threat data using distributed deception. What is threat data? Well, threat data is anything like an IP address, a URL, malware, right? These are things that we call IOCs. That's basically threat data. Another way to put this, right, if there's non-technical people in the audience, like a spouse or a friend or whatever, right, if you're not into tech, think of it as like someone's trying to kill you. That's threat data, right? You can't really do much with it. To make it actionable, you need to put some context around that. So I'm collecting all this threat data, and I'm storing it somewhere. So we're going to talk about how am I collecting that. The next part is this distributed deception piece. Now, deception is, I'm using a honeypot, essentially, is what I'm doing, right? So there's a honeypot called Cowrie, and I'm using that as the deception technology. So a threat actor logs into the system. They think it's a real Linux system. All the commands that they would do on another Linux system would work, and I'm capturing all that information. So they log in. They're looking at files. I see all that. They're trying to exfil things. I see that. They pull down their tools. I'm capturing all of that, right? So they're being deceived into thinking that it's an actual legitimate system. And the distributed portion of that is I'm putting these systems all over the place. So I have systems in Asia, in the United States, European Union, specifically like Finland, Germany, California for the United States, and then India, right? So they're distributed all across the globe, and they're collecting threat data, which I explained earlier. So here's the agenda for today, right? We're going to look at what is this architecture? How am I collecting the threat data? How is it distributed? We're going to take a look at that. We're going to look at the automations. So if I spin up a honeypot, I'm not doing all these manually, right? Think about having 200 honeypots out there and having to manually configure, install Linux, configure the honeypot, whatever I'm using to extract data, I'm configuring all that manually, doing that 200 times. That's, in 2022, that's not what we want to be doing. So we're going to look at how do I automate all of this? And then what are my observations? This is probably the piece that most of you are interested in, right? What are you observing? I've been doing this for about 4 years, right? So I started this a long time ago as like an individual research project. I'm like, hey, I want to see what's happening out there. Yes, you can go to malware archaeology, all these different sites and download malware. You can read reports, but there's nothing better than like that primary research, right? It's like, I know this occurs because I saw it, right? So that's kind of why I did this. So it's been about 4 years, and I said, hey, I can turn this into a talk and share the information with people that are interested. So some of you may be interested in architecture, and that's all. You may be interested in how am I automating it, and some of you might just care about, hey, what is he seeing? And then we're going to look at some takeaways. All right, so it starts with the honeypot, right, the deception technology. Every single honeypot uses Cowrie, which is a medium interaction honeypot. You have low, medium, and high. The higher you go, means the more realistic it looks. Think of B-sides. You find a laptop laying around somewhere, you pick it up, you open it up, oh, it's Windows 11. You start typing commands and they work. The attacker sees the same thing on that honeypot. Splunk is how I extract the data. So there's a Splunk universal forwarder. Those of you that are familiar with Splunk, it's the equivalent of like WinLog beats or file beat. It's the same thing, right? It extracts the data from some endpoint and feeds that data to some centralized SIM. So I'm using Splunk here because I have a lot of experience with Splunk, and that's just what I use in this environment. And then every single honeypot is with a different provider. So it's not like I spun up an AWS EC2 instance and they're all in AWS and they're in different regions. It's a separate provider that's in, for instance, India. So a provider in India, it's hosted there. If it's in California, it's a VPS provider in California within the United States. And of course, like I said, they're all running Linux, either Ubuntu or Debian or some flavor of Linux. So none of these are Windows honeypots. All right, here's another one that's in the European Union, exactly the same, and another one in the United States. So that's what I call layer 1. Layer 2 is the seam level. So all the data gets pulled from all those honeypots that's geographically dispersed or distributed, and they get fed to a SIM that's in AWS. Then we have layer 3, which is the Splunk search head. I use this to interrogate the data that's in the Splunk seam, and then that data gets fed back into visualizations or any kind of data that I can manipulate. And then from that Splunk search head, I have a lot of the automations that push out the products, right? So one of the products is a CSV file with various things that we'll cover later on. And then more recently, AT&T has this thing called OTX, or Open Threat Exchange. Essentially what it is if you found like malware or you found an IP address or some kind of IOC, you can publish it to their site in the form of a pulse. And the great thing about that is if I found something and you found it, that can get published. Basically, anyone that goes there can say, hey, 3 or 4 or 5 people saw this exact same indicator, so that gives you a little bit more confidence that it's probably malicious. All right, so that was the architecture, right? You can take a look at that and generate any questions you might have later. And then, so how do I automate that infrastructure? Well, there's 3 forms of automations. The first one is Splunk, right? So Splunk has this thing where you can write a query. Let's say the query is, hey, how many domain controllers do I have in my environment? You're going to get some metric back that says 8, 9, whatever that number is, right? Let's say every morning you come in and you're tasked with running that query. Well, that's kind of monotonous, right? How do we automate that? Splunk lets you write that query, you can save it, and you can schedule it. So every morning you come in, it's already ran, and you get your metric. Of course, you can create dashboards and all kinds of things like that, right? So that's the first type of automation that I'm using. The second automation is something near and dear to my heart. It's called Ansible, right? Some of you may know it. Puppet, Chef, or some other tools out there that automate things. I use this to deploy the honeypot. It also deploys the universal forwarder and any other configurations that I have. So I basically run a playbook, and I have a honeypot that's provisioned in a few minutes. And then I have feed generations, right? We talked about this a little bit earlier from the Splunk search head. I have a Git repo that has the CSV from 2 of the products, and then we have the ALIENVAULT OTX Pulse that's created. So don't worry about trying to figure out what this means or if you can't see it. Essentially what it does is I extract all the IP addresses from all the data from all the honeypots, right? These aren't IP addresses that have scanned the honeypot, that have like pinged the honeypot or some kind of interaction. These are IP addresses that have gained unauthorized access to any one of the honeypots, right? So that's the criteria for making the CSV list. The other thing that I do is I enhance the data by adding like first time I saw this, last time I saw it, the geolocation, and I also looked at how many sensors have seen this particular IP address, right? So if the IP address is in there and it said, and there's a column that says number of sensors and it's 3, that means, hey, 3 honeypots have seen this particular IP address and it's gained unauthorized access to that system, all right? So I'm going to recap. It's not scanning, right? It's not pinging. It's actually landed on that box and performed some kind of execution of code. And then the other thing that I kind of did that I thought people would find value in is I took the Tor exit node list and I said, hey, how many of these IP addresses that have done this bad thing are also a Tor exit node? And I put that as a field. And you can see that here. I'm not sure if you can read it or not, but that's what it looks like. The part that I have outlined is the time that it runs, which is 2 a.m. every single day over the last few years, right? And it generates that. And then if you want to view it, you can go into Splunk and also view that report. And this looks at all the data. This is the other product that's generated, which is a URL feed. So when someone logs into that system, right, whether it's automated or it's someone manually logging into one of those honeypots, they reach out to pull code down. Well, I capture that URL, and that's what's generated in the second CSV product. So bad guy logs in, they say, hey, I'm going to go out to my infrastructure that's in Russia, China, wherever it may be, right? It could be US infrastructure as well. And let's say it's their cool C2 tool that's tarred and gzipped. Well, I capture that URL string that they use. I put some of the same metadata around it that I do for the IP address field, so first time, last time, number of sensors. But I do one additional thing. I look at the data, the domain names that's in there, and I say, hey, you know what? there's an Alexa top 1 million domains. Let's pull that out. And the reason I do that is a lot of people take these lists, right, blacklist, block list, whatever you want to call them, and they just put them in their IDS. They don't filter them, they don't sanitize them, they don't look to see. They said, hey, someone already did the work for me, it should be good. And you may find things like 8.8.8 in there, which you don't want to block, right? Those of you that know, that's basically Google. So I pull it out just as kind of like a due diligence for people that's going to use this blindly. It's not foolproof, though, because a lot of what I've seen is not domain-based. They're not going out to www.badguy.com, right, /cooltool.zip. A lot of times it's IP-based. So the Alexa top 1 million is domains, not IPs. So I'm not going to capture the IP addresses that are in there that's potentially like Google domain or Microsoft infrastructure. And this is what it looks like. And then now for the honeypot deployments in the Splunk UF, right? I use Ansible, and Ansible has something called a playbook. So you can do individual tasks, or you can run a whole playbook that has all the tasks that you want to do. And there's a thing called roles that containerizes all the things for a particular action that you want to do. So I have a Kari honeypot, and I've customized it, right? So this is not a default install of Kari. There's things like, for instance, when you install Kari, it used to be Richard as the default user. So I see attackers logging in, and they're grepping for the Richard user to see if it's a honeypot. The current version of Kari has Phil as the default user. So of course, attackers are going to adapt, and they're going to grep for the Phil user, right? So I don't have any of those users in there. I have about 10 or 20 users that I just create, and I throw those into the honeypot. So attacker logs in, they grep, they see a bunch of random users, and they keep doing what they're doing. So coming back to the Ansible playbook, there's a lot more code, right, written in YAML behind this, but it doesn't make sense to show it if you want to see it after. I'm going to do a demo of it, of deploying a honeypot, so you can see what it looks like. But this is essentially the code in the playbook that runs a bunch of other code behind the scenes. All right, so we're going to go into a quick demo of what it looks like. This is deploying one honeypot. So it's only doing the Kari deployment, right? This is not the full deployment. So you can kind of get an idea of what it looks like. If you've never seen Ansible execute before, this is what it looks like. There's one particular host that is being deployed. So where it says beer, that's one host. If it was 200 hosts, there'd be 200 hosts lined up across there. Those of you in the audience that are like, hey, well, you wouldn't do this with 200 hosts, there's a thing called Ansible Tower, and that's what you'd essentially use to deploy at scale. If you go to Kari's website, let's say you Google Kari right now and look at the installation steps, there's about 7 steps that they set up. So what I did was I went through each step, and I basically created an Ansible task or rule that completed that. And I added about 1 or 2 additional things. So like at the end, you can see it's checking for the SSH port. The default port is quad 2s. I'm checking to see if that port is active, and that lets me know, like, hey, the honeypot got installed successfully. All right, so now for the GitHub data feeds, right? So I talked about the CSVs that are generated. You have an IP CSV, and you have a URL feed. Well, those sit on the Splunk index or Splunk search head, right? How do I get those out so that other defenders can use them? Because it does you no good if I have them and you can't get access to them. Let's say you want to use them. Well, what I do is I run I have 2 bash scripts, and it basically compares the CSV that gets generated by Splunk with whatever's in the Git repo, and if there's a difference, it commits the change and pushes it to GitHub. So every single day, around sometime after 2 o'clock in the morning, a new file is going to get pushed, so you can pick that up. And then the ALIENVAULT OTX Pulse, same thing here. If you can't read the URL, obviously I can give you the slides after this, or you can just Google it. It's called Fakelabs Project. Right? The great thing about the Pulse on ALIENVAULT is it allows you to convert that CSV into other formats. Right? This is what it looks like on ALIENVAULT. And remember I talked about being able to correlate that with other organizations or individuals that have the same findings. So this is my actual Pulse that I've submitted, right, based on the data we were talking about. There's at least 3 indicators on here that have over 50 other people that have identified the same indicator, right? So I'm seeing this in my honeypot, and you have 19, 78, 57, and 33 other people that have seen different IP addresses doing different things. And like I talked about, right, if the CSV format isn't something for you, we have OpenIOC, and we also have Stix and Taxi. So if you're using MISP, you can convert it to one of those formats and import it into whatever platform it is that you're using. observations. Okay, so this is the part that most of you are probably interested in, right? What have I seen? I set all this infrastructure up. I did all the automations. You don't care about the automations. Right, what have I seen? Okay, so the number one thing, right? We talked about this. There was a talk this morning talking about like passwords, right? This thing is beat to death at all the security conferences, any webinars you've watched. They always talk about it, and I think it's relevant because it's true, right? We talked about IoT, XIoT. All of them have default passwords. You buy you know, any off-the-shelf device, and it says, hey, you need to configure it. It's going to have like whatever brand and then password as the password, or admin, right? So out of all the data, right, we have 8 million events. What's like the top 10 passwords that I've seen? Well, the number one password's 1, 2, 3, 4, 5, 6, right? No surprise there. Yeah. So I did some research, and I was like, I remember there was like some list somewhere published, right, about like the top 10 whatever passwords. And it turns out that Forbes did a study of the 100 worst passwords in the world. And the number one password in that list was 1, 2, 3, 4, 5, right? 1, 2, 3, 4, 5, 6, which is what I have here, was number 2. So it's still important, right? We had a ton of talks that talked about, you know, admin, password. And we'll see, like, when I go on and we start looking at some of the malware that I was looking at, they have these, like, basic passwords hard-coded. So they're not looking for complex passwords. They're not having, like, you know, we talk about a billion password list or whatever. They're not looking at like 10,000 different passwords. They have like 10 passwords in the list, and they're searching for those, and they're gaining access to systems. Right? So I thought it was important to communicate that here to you. And if you like pie charts, right, there you go. You know, almost half of the passwords that I see are 1, 2, 3, 4, 5, 6. Okay? All right, so what else have I seen? IoT malware, right, or XIoT, if you will, is basically what I see. A good 80% of it is that. And they're Mirai variants, right? Mirai, what is that? It's 2016 was discovered, basically a large botnet that took down a bunch of different organizations. Krebs on Security is one of them. OVH, which is a provider over in Germany. And a lot of the attacks that happen were really collateral damage, right? So you have this huge IP space. Let's say they're targeting like the Sony network, and some other company happened to fall within the IP space. It was collateral damage. It wasn't necessarily a target. So I see a lot of Mirai variants. That Mirai code was leaked, and a lot of other threat actors said, hey, there's this very nice code base that's out there. I don't have to do any research, right? I don't have a security team. I'll just take this code and repackage it, and that's what they did. And you have a bunch of different variants. Now, what I noticed is there is no industry standard for naming the variants from Mirai, right? So let's say, you know, you decide to, hey, I'm going to take Mirai and I'm going to make it my own because there's some vulnerability that came out there, and I'm just going to adjust the code. And you have some string in there, right? Let's say you put like Sora in there, and somebody discovers that variant out there, they name the variant Sora. It's really just based on the binary name, some particular string in there, or maybe some output that's generated from the binary. That's the only that's the only rhyme and reason to how they name these things. And I picked an example to show you. This happened in June of this year, right? It was discovered June of this year. It's called the RAPPERBOT. And the only reason it was named the RAPPERBOT is because it drops a YouTube link to a rap video when it executes, right? Does that look like any kind of like IEEE standard for naming a malware? No, right? It uses parts of the Mirai code base, right? It's one of the variants. The research out there says it's just acquiring access, right? They don't see it doing anything malicious other than accumulating access. And then there's a unique identifier. If you run strings on the binary, it's going to pop this out, and what it does is as it scans the internet and connects to SSH servers, it puts this string in there, right? So that's an IOC, if you will. I would use more than this as an IOC, but that's one of them. Some other observations, right? As you're running strings or you're throwing things into Binary Ninja or IDA or whatever thing you were doing, if you're doing that, I see things like this, right? Cha-cha sliding across SSH. RN is like right now. So I thought that was interesting to share. Like they do have a sense of humor, and they do put some things in here. And then this is another thing. I see this a lot, right? So there's a ton of Perl scripts. They're basically taking the malware. There's a site called PacketStorm, and there's a ton of exploit code there. They download this code, and they just change the attribution, right? So this was actually written by a group called MALWARE. I can't remember the exact name, but they take that same code, they'll either cut out the header or they'll put their own name in there. And all it does is it executes on your server, connects to an IRC server, and then from that IRC server, they can say, hey, attack, Sony network, or attack this other IP. Or let's say you're playing on some game server, Quake or whatever it is, and they know the IP address. This is one of the reasons why people say hide your IP address. They can have their 50,000 different zombie computers basically attack your computer. And that's essentially what this does. And then this is kind of like indicative of MALWARE and the different variants. Essentially what this does, if you can't read it, don't worry about it. It's trying to find a directory that it can enter, and then it downloads every single architecture. So it's saying, hey, as I'm going to compromise these IP cameras, the refrigerators, the thermostats, the whatever it is that's out there, right, that should or shouldn't be connected to the public internet, I don't know what architecture that is. I don't know if it's a Windows laptop, right? Like as I look across this room, like I don't know if that's a Mac laptop. I don't know if that's Windows laptop that you convert it to a Linux laptop. Like I don't know what the OS is. So if I have one piece of software that I'm trying to execute, it may or may not work. But if I want to compromise everybody in this room, I'm going to say, okay, what architectures are out there? You have ARM, you have Intel, right? So x86. So what I'm going to do is I'm going to take every single architecture I can, and on the screen it basically says PowerPC, ARM. If you have a Raspberry Pi, that's going to be ARM architecture. The M1, the new M1 Max, those are ARM, right? And I'm going to download all the different versions that I have and execute them till one works. And that's essentially what they're doing. Then we have another malware called Dota malware. Anybody take a guess at why they call it Dota? Because it's called Dota. The tar.gz is dota.tar.gz. That's the only reason why they call it the Dota malware, right? So when you extract this, it's going to have, I actually wrote a blog post on this, so if when I give you my blog later, you can look at it, and I dived a little deeper. But there's two binaries in there. There's a 32-bit and a 64-bit binary called TSM. That's responsible for going out and scanning other systems and compromising them. Then you have two other binaries called Anacron, and they change the names up. So as you get these different tar.gzs, there'll be different names in there, but they essentially do the same thing. There's going to be two that go out and scan and capture other machines, and then there's going to be two that's responsible for Monero mining. All right, Monero is basically it's supposed to be designed to not be traceable. And then shell scripts. There's a ton of shell scripts that basically do the housekeeping, responsible for executing the different binaries and setting up the crypto mining. And then I found like this random obfuscated file that was on the system. It was basically basic64 encoded, and then once you decoded that, it was Perl obfuscated. If you're not familiar with obfuscation, think of like a string of code that says print hello world, but instead of saying print hello world, there's like 50 lines of code that essentially does the same thing, right? That's what they're doing, is they're making it really hard to read what the code does. And then here's just an example of a Huawei exploit, right? So they took the Mirai code base, took the exploit for the Huawei device, and they packaged it up. So what they're doing now is instead of using a password to get into a system, they can say, hey, let's see if we can exploit a system using this exploit and gain access that way. So if you have a really good password, right, you said, hey, I'm going to change the default because I heard I shouldn't be doing that, and you put in a good password, well, they can still exploit your device this way and gain access and then scan the other systems. Here's another one. I had no idea what TotalLink was at first, but then when I Googled it, I saw it was another, like, basically Wi-Fi router you can buy. What was interesting about this, and kind of some feedback for defenders out there that are looking at strings within binaries, so this is all plain text, but if you XOR the binary strings using the default Mirai code, which there's a default key, so XOR, I'm not going to get into details of that, but if you're familiar with that, basically don't just look at a binary that reveals strings as, okay, this is not encrypted. There may be encrypted strings in there, which there is. This particular one revealed the payload for the TotalLink exploit. And then here's another demo, right? So people think that a lot of the attacks that happen on the internet are all automated. Well, there's actual individual threat actors that land on systems and don't realize that it's a honeypot. And here's an example. So the great thing about Kari is every single attack that happens on the system, once they log in, it records what they're doing. And there's a tool that allows you to play back all of those attacks in real time, or you can speed it up. So just take a look at this, and I'll kind of narrate as it goes through. You'll notice the command line, when it comes up, it'll say AWS. That's arbitrary. So I can make that whatever I want. And I kind of made it look like AWS, so they think that, hey, this is probably an EC2 instance or whatever. Notice that there's no default Phil or Richard user. They're trying to basically set the system up so it doesn't record their history. They're checking the architecture. Okay, what kernel version is it vulnerable? Some basic reconnaissance, right? Nothing about what they're doing right now is advanced, essentially. They're checking to see, how many CPUs do we have? Maybe I can mine crypto on here, right? There's only 2 cores on there, so nothing too fancy. Looking at temp directory to see if there's other files. Maybe they can mingle their files there, and then they decide to go to dev shim, and this is where they're going to pull down their files. So what's great about this is I now have a copy of that package, right? Whatever payload that is, whatever tools they have in there, I now have a copy of that I can analyze, I can build detections around, and pass that and share that with the rest of the community. The other good thing about it is they can't use that to attack other people, right? So let's say they pull down whatever nation-state tool or whatever tool it is that they have. They can't now take that and attack other systems. So the great thing about running a honeypot, if you're talking about what are the risks, that's one of the things that Bobby designed. You cannot attack other systems. So you'll see they'll try to execute different code, and they'll get frustrated, like, why isn't this working? It's executable. They'll try to download it again. It doesn't work. And then something that's pretty great is they download another set of tools, right? It's called fresh.tgz. So I now have 2 copies of different payloads, if you will, that this particular attacker has. Right? And while we were going through this, you notice that it's not automated, right? This is actually someone typing these commands. There's where they download the other tool. And I said, thank you very much. Right? They try to extract it. It extracts. Now, if you're not familiar with Kari, I'm just going to explain it real quick. If you try to cat like a text file or any plain text file, it'll actually show you the output. So the attacker is thinking, okay, this works, but why doesn't the binary work? If they cat a binary, there's like a standard output that it shows just by design. Which is another signature for Kari or a honeypot, but it won't execute it. And so that's the frustration I see a lot of times is it won't work. They try, and then they give up and leave. All right. The reason he tries putty or she or whomever it is, they're trying putty to see if, okay, is this a honeypot? Is it going to run any command I type? It doesn't work, so they still believe it's a real system. There you go. They're getting the output from one of their plain text files, so they're like, okay, I can see the output, so it's probably not a honeypot, and then they just eventually give up because they can't get anything to work. Cool. So H2 Miner, this is not a Mirai variant. This is a different kind of malware. It essentially scans for vulnerable Redis servers, right? And then what I've noticed with a lot of different malware is they use mass scan to scan other systems. Now, what's really cool about this is everyone else is trying to scan the rest of the internet to find vulnerable things. But if you're not familiar with those IP addresses, those are basically what's called RFC 1918, or basically your internal non-routable IP addresses, right? Meaning you can't connect to these on the internet, or you shouldn't be able to connect to these on the internet. So what they're doing is they're saying, hey, I got access to this organization. What other internal systems are also vulnerable, right? Because most people, I had a conversation with a system administrator, and he was asking me, hey, why do I need to secure my server when we have a firewall, IDS, all this stuff on the outside and it's protected, right? Basically, you have like 6 deadbolts on your front door. Why do you need to put your jewelry and your money and all that stuff in a safe and all the other stuff? Why can't I just leave it out on the kitchen counter? And I said to him, because attackers, once they do get in, or if they're already in, or insider attacks, right? We talked about insider attacks in some of the other talks. They're going to scan inside because they're like, hey, your security posture within your organization is probably not as fortified as the perimeter. So just another example of why it's important to either practice zero trust, since that's the buzzword we're using nowadays, or the assume breach, because once they get in, how protected are you there, right? And then this is another example of the passwords that they're using. So this was hard-coded in a shell script for that particular exploit. Right, if you can't read it, it's basically root, Redis, Oracle, password with the ampersand in there and a 0 for the O. And it was only about 10 passwords in there, right? Not 10,000, not 10 million, right? They weren't reaching out to some server and pulling down a password list. It was only a handful. And they're getting access this way. So that's telling you something. And where are they scanning? Internal servers. Other observations. So like I said, a lot of the binary strings, if you're looking at malware samples and their Mirai variants, a lot of the attackers aren't changing the default string, which is basically dead beef, right? Or when you're looking at disassembly in Binary Ninja or IDA or whatever you're looking at, it comes up as 22 basically, right? So you'll see 22. If you can read C code, that's basically the function for decrypting it, or encrypting it. And then here's what it looks like when you see it in the strings, right? So the first one, PMMV, that usually decrypts to root. So in about 4 or 5 lines of Python, you can essentially brute force this key space to figure out what the encryption, what the key is for it. Another observation is basically crypto mining, right? I saw this particular config in one of the binaries, and I was trying to figure out, like, what does this user thing look like? So I went out to the GitHub, and I saw it was the wallet address. And this is what it looks like in the actual binary. So I was like, okay, I got the wallet address. I found about 3 unique wallet addresses, but like I said, Monero is designed not to be traceable. So if you take this wallet address and you plug it into, like, the Monero Explorer, like there's a, for those of you into crypto, there's different explorers, right? So you have an ETH Explorer, you have a Bitcoin Explorer, you can plug a wallet address in and you can see, like, how much funds are in that particular wallet. Well, with Monero, when you do it, it says, hey, you're trying to see how much funds this dude has in his wallet. Sorry, you can't do that, right? It has some quirky message like that. But the other thing that you can take away from this is, you know, by default, TLS is disabled. They deploy it the same way. TLS is disabled. So if you're trying to look for it, I believe it's a 95-character string, so you can write some snort or suricata rules to kind of detect this on the wire. And then a lot of the pools, if you do want to find out how much funds they've accumulated over time, some of the pools have a website tied to them. You can go to that website and then plug in the wallet address, and it'll say, hey, they've made, like, you know, 10,000, 20,000 since they've started using that particular pool. It's not how much they have in the wallet in aggregate, just how much they've mined on that particular pool. And then another observation is hard-coded user agent strings, right? I've been a part of organizations where they say, hey, let's baseline the user agent strings and just look for this. Or Cobalt Strike has this user agent string, let's look for that, right? The danger with this is, let's say your organization baselines your user agent strings, but your user agent string is in this list, then this is going to fly under the radar, right? So when you're doing things like this, just have a lot of other things that enhances the confidence in whatever detection you're building. So don't just look for a naked user agent string as like, that's good. This particular malware, what it does is every time it goes out and scans and tries to connect to another system, it randomizes which user agent string it uses. All right. So what's the so what? What's the takeaway, right? Like, what's the point of all of this? If you're a non-tech person, you should be able to get something from this. The whole point of all this is there's a lot of noise on the internet, right? You plug a system, a server, let's say you spin up a VPS, you take your Raspberry Pi and you plug it into some public-facing internet thing, there's going to be a ton of scans. Most of you know this, right? So that's the first part, a ton of internet noise. What are they trying to do? They're trying to build a botnet. They're trying to take over your computer to basically leverage it as a part of their army. Your computer can be an IP camera, your smart thermostat. It can be, you know, your VPS in the cloud. It can be a honeypot, whatever it is, right? Their goal is to capture as many computers as possible and turn them into zombie computers that they can basically press a button and say, hey, all of these computers that I own, I want them to attack XYZ system. The other component to this is they want to be able to lease that out, right? So right now you're not using your vehicle. What if while you're here at B-Sides, you could say, hey, I can make money with my car because while I'm at B-Sides for 3-4 hours, you can drive my car and I get paid, you know, $1,000 for the time that you have my car, right? That's essentially what they're doing here. They're saying, hey, I'm not using this botnet. I don't need it for anything right now, but if you want to use it for a week, pay me 10 grand and you can have it. I believe the business of the talk, a couple talks before this, they talked about it was like $30 an hour to rent different malware or whatever. So they're basically building the botnet and then making money off having that. The other thing is mining. There's a ton of mining. Like most of the malware you see have a component to attack other systems. They have a component to exploit other systems, a ton of things. But the second thing that I see the most is kill every single other Bitcoin or crypto miner that exists on that system by name. I believe there's one malware I saw in there that had like probably 50 different names for other competing malware things that could be, or miners that could be on a system, and it kills all of those processes before it runs its own. So That's the second thing that I see in there, specifically Monero. I have not seen any other types. I'm not saying that there aren't, but I haven't particularly seen that. I mostly see Monero and the XMRig, which is a public, it's an open source miner. And then the last thing that you can take away from this, right, is opportunistic threat actors. You saw when I showed you the example of like the log of someone logging in. Because they know there's a lot of noise out there and there's a ton of scans, most people just ignore it. They're like, hey, it's just noise. Everyone gets scanned. It's port 22, they're going to scan it. 23, they're going to scan it. 80, they're going to scan it. Like, what's the point? Well, attackers know this, and so what they're going to do is they're going to fly in under the radar, and they're going to say, hey, within this noise, I'm going to try to like use the same password, right? Admin password, or whatever the default passwords are, and I'm going to see if I can compromise the system. But they're typically going to be after things like intellectual property, right? They're going to be after whatever thing that's valuable there. Maybe they're looking for, maybe right now you're connected to Wi-Fi, right? Everybody has the same password. But you have open share on your Windows computer, and you have a bunch of pictures on there you probably shouldn't have on there. Well, anyone in this room that's a part of that network can see that share and connect and download those pictures, right? That's a true story. Happened to me during a deployment. I had a soldier. He didn't know anything about security. I wasn't in security at the time. I was still a mechanic, but I was deployed. And yeah, someone basically got his pictures of his wife that he had on his computer, and he didn't know how. He just said, hey, someone hacked my computer because the pictures ended up somewhere, right? So these are things that are happening out there. When you go back home or when you're conversing with your colleagues, this is essentially what I want you to kind of take away is these three things. Here's my contact information if you want to reach out, if you want to collaborate. Those Splunk queries that I show, if there's any Splunk experts in here, if you want to tell me how I can optimize that a little bit better, or tell me how jacked up I am because you could do it in like one line, hey, by all means, reach out to me on Twitter or come down after, because I'm always willing to learn and grow. All right? Are there any questions? Okay, so the question is, there's things like VM escape, right, where they can exit the VM. So with the honeypot, can they escape from that and land on a system? Sure, there probably is. I'm not aware of any right now, and there's not been any published. How I mitigate that is there's nothing of value they're going to get from basically doing that, right? So if they escape, they'll land on the VM, and they can maybe wipe all the logs. But none of this infrastructure there's no attribution, right? So it's not attributed to my company. It's not attributed to any particular organization. And I'll be able to detect it rather quickly just because of some detections that I have in place, right? So the answer to your question is anything is possible, right? Tavis Ormandy, who's a guy that's like hacked a lot of things that people thought wasn't hackable, and there's a ton of other folks that go to pwn to own in these competitions, and Apple releases a new product, and then the next day it's owned, right? So we know this happens. Does that answer your question? Okay. There was another hand. Ma'am?
You talked about changing the users so that it wouldn't look like it was a honeypot. Are there any other things like that that you do to make it look more realistic?
Yes. So there's a ton of stuff that Kari does by default that's signaturable. One of them is the process list. If you don't change anything, it looks like I believe it's June 2021 or something like that. So you can edit some of the files. You can basically edit the source code. It's all in Python. And I changed that to a different date. And you just have to kind of go through the source code and look at it. You can log in yourself and see what some things that are static. And I believe some people have written some blogs about some things out there. The file system by default doesn't show a lot. So you have to I would look at the docs, and I can talk to you after this if you want, but there's a ton of stuff that's signaturable, but some of it's not really worth the effort because a lot of people that log in, they're not looking for that. They're doing the easy things. Does it have the Richard user? Does it have the Phil user? Is the date, June? Because when you do the process list, it's exactly the same every single time. I don't know why most people don't see that, but it's pretty funny. And then, of course, like when you do uname, if you don't change the default, Kari has a default kernel version that's in there. So I changed a lot of that, and I automate it so I don't have to go through and fix it. So right now, if I wanted to change the versions on all my honeypots, I would just go into the YAML, change that particular config, push it out, and it's done.
How long are you letting it run for? Like if somebody logs in, starts downloading packages, do you recreate it 2 weeks later, so therefore it's kind of fresh for somebody else to come back into it?
So that's done automatically, yeah. If someone logs in, I mean, you can have concurrent users logged in. So it's not a one at a time type thing, right? So if they log in, they download like a gigabyte file, and they come back again 10 hours later, 2 days later, it's hands off. I don't have to do anything.
But like 2 months from now, like it's still the same thing, or do you create a fresh honeypot?
No, I don't refresh it other than the normal updates to Kari. So if Kari has an update, I'll do a git pull. I'll look at the change log to see what's changed and then make sure there's no disruption, and I'll do a pull. And so I don't know how many people know about Git, but basically you can pull down the code. It's like download, updating it. So other than updates, no, I don't change anything. Now, if I see there's new things that are signaturable, I will change it, right? So if I see a trend of like every time they connect, they do a grep for something, and then they log off right away, I'll look and see what that thing is, and then I'll adjust.
So I have 2 questions. What are you spending on the architecture per month for like AWS?
So this is one of the questions I predicted would be asked. It's less than $100, right? The biggest cost for me for this, there's a company called SkySilk. You can run a VPS. I was a part of the beta program. It's like $4 for one VPS, right? And that could be a lot of money for some people. But the biggest cost is storage. And so one of the things I'm trying to do is move to something called Smart Store. Splunk has a way for you to push the data within Splunk to S3. And that's really optimized for things that you don't want to search long term. If you're doing a lot of searches across a long length of time, like a month or something like that, you don't want to do that. But if it's only like 24 hours, 48 hours, then that's fine.
Are you also noticing like any difference between the areas that you have the honeypots, like geographically, like different attacks?
Yeah, definitely. In different, like in the Asian region, there's a lot, the attacks that happen over there and the malware that I see there, I don't see in other places, like US or the EU, right? I don't have a large sample size, that's just what they've attacked and what I have. Obviously, cost is a limiting factor for me. I'd love to have more, but no one's funding my personal research. This is something I'm doing on my own time.
So, what's your Splunk license, and how do you get Splunk for free, since Splunk is?
So that's easy. So Splunk allows you to get 2 types of licenses. You can get a developer license that's, I believe, 50 gigs, and then one that's 10 gigs. The 50 gig one has like this big banner across that says like your email and all that stuff, and then there's one that's 10 gigs. So I basically apply to Splunk and I say, hey, I'm a developer because I create apps for the platform, and that's how I get the license. The amount of data that I see doesn't exceed the license that I have.
On this honeypot, I know you talked about configuration. I'm assuming there's a lot of configuration or places where you can't configure what commands will successfully run and not. And I'm assuming is that the mechanism you're using to prevent them from cleaning up their actions, right? So downloading all these things, is that how you're preventing them from cleaning up afterwards?
No, Kari by design doesn't allow that to happen. Yeah, so the whole point of it is to capture those artifacts, and it wouldn't really be good to do that, because then if you created commands to prevent that, then they could probably bypass that. So yeah, by design, artifact gets on the box, it's stuck. There's even mechanisms to push it to S3 and these different platforms. If you look at the config, there's like a ton of outputs. You can send it to MISP, you can send it to VirusTotal, you can send it to the HoneyNet project. I mean, there's just a ton. I just use the Splunk UF to extract the data because I'm doing some manipulations with it, right? Like I'm basically normalizing it and creating different event types and all these things.
Follow-up, have you ever seen any person that got on the box that was successful in maybe trying to bypass any of those mechanisms, like notice that you're sending stuff to Splunk, or notice, maybe a specific process or something on there that kind of tipped their hand that this is a honeypot?
No, I have not personally seen anyone escape the honeypot onto the whole system. I mean, if they did, I just didn't notice it. But I haven't seen anything suspicious with any of that. Obviously, there's no login generated if they land on the system. But I log everything, and there's access controls in place so that only certain IP addresses can access them, right? So for instance, my home address is the only thing that can touch the AWS, the Splunk indexer where all the data goes. And the same thing with the honeypots. The only port they can do is basically the index port, right? Which is whatever I configured it to be. In the back.
What about making this more network connected to the honeypot, a little bit more complex to see about additional attacks and lateral movements?
So what kind of complexity are you suggesting?
Maybe a few extra servers, like they were going after the Rita servers, so maybe throw one in there just to see what they do with it.
Yeah, that's a good idea. I haven't done that. So some of my next steps is to add like web-based honeypots to this, right? So there's Snare and Tanner as a product that's out there that I'm kind of evaluating. But that's a good idea as well. I just haven't done that yet, right? Any other questions?
What kind of device are these, is this masquerading as an IoT device, or what do they think they're getting onto?
They don't know. So essentially, all the honeypots have port 22 exposed. So all they know is that port 22 is open, and I used admin and password, and I got in, or I used root, and I got in. And then most of it's automated, or if they're doing it manually, they're doing their reconnaissance to figure out what it is, right? There was someone I met last night that talked about adding honey tokens inside the honeypots, right? So attacker lands on the box. Yeah, that was you, Chris. Basically putting like AWS tokens in there, or putting like brocade configs, or anything that would kind of entice the attacker as they're looking around to take those credentials, and maybe you can figure out what they're doing with that, and kind of do some analysis there. So that was a pretty good idea. I think we talked about collaborating on seeing what we could do there. Good question. Any others? It's the end of the day. Everybody's ready to go home. Parking lot dash. Cool. All right. So my name is Michael Edie. Once again, thank you. Oh yeah, swag. Let's see. Okay. This is a question I have pre-prepared. Why do I filter out the Alexa top 1 million domains from the URL list? I saw that hand, black shirt, go up first. No, not really, no.
I guess just trial and error.
Oh, is that Daniel? Who's talking?
Me.
Oh,
I'm guessing just trial and error, right? You want to filter out the noise. Everything's filled with noise, right? The first step in any real program is, hey, my data was a loop, let me just try and cut it down.
no. Let's go back in the back. Yeah, you. Mhm. Yes, there you go. I mentioned that in the talk. So essentially, people will take the list, they'll dump it in their IDS, they won't check it, they won't look at it, and so I'm kind of helping them like avoid those mistakes, right? So I filter out the Alexa top 1 million, which is a list of like known good or supposed to be known good domains, right? So Google's going to be in there, Microsoft's going to be in there, whatever. You can download that site and see what it looks like. All right, another question. Who remembers the IEEE RFC I mentioned about those internal IP addresses, the 10 dots, the 192? Are y'all part of this? Okay, go ahead.
Is RFC 1918?
Yes. All right, good. All right. Just want to say thanks to BSAS for allowing me to speak, and thank you to the audience for coming and listening. Have a good night.